Here we use the population decay model given by this equation, that is P of t equals P naught e raised to the power of negative r t. P naught is the initial population and R is the decay rate and T is the time in years. And P of T gives the population after T years. So let's use the given information, that is in year 2011, and this means we can consider this year 2011 as T equal to 0. The population is 13,000. So therefore the initial population is 13,000, and this means P naught equals 13,000. So I'm going to plug in P naught equals 13,000 into this model. So therefore this becomes P of t equals 13,000 e raised to the power of negative rt, and this decreasing rate is 10.3, which we have to write in decimal, that is r equals 10.3%. Let's give this in percentage, that is 10.3 divided by 100, and this equals 0.103. So therefore R equals 0.103, which we plug it here. And so it becomes a negative of 0.103 t. So we have written this population model given the situation. So P of t equals 13,000 times e raised to the power of negative of 0.103 t is the population model. Now let's answer this part A question, that is we have to determine the population size in 2025. So 2025 corresponds to T equals 2025 minus we subtract the beginning of the year, that is 2011, and so this equals 14. So T equals 14 corresponds to the year 2025. And so to determine the population in year 2025, we have to plug in t equal to 14 into the population model. So therefore we get P of 14, and this equals 13,000 times e raised to the power of negative 0.103 times t, replace t by 14. We just clear this. So we can plug this expression into the calculator, and when we do that we get approximately 3074, and this is approximated to a whole number. So this is the population size in the year 2025, and this is the answer for part A question. Now let's answer part B question, and here we have to determine the year in which half the population will be left. That means the initial population is 13,000. So half the population will be 13,000 divided by 2. And so this equals 6,500. So we have to determine at what year the population will be 6,500. For that, we plug in P of t equals 6,500 over here. And this equals 13,000 e raised to the power of negative of 0.103 times t, 0.103 times t. Now we have to solve for t from this equation. First, I divide both sides by 13,000, and here also by 13,000. So these two 13,000 gets cancelled, and I can cancel these two zeros, and this is basically twice of 65. This is 1 times 65, and this is 2 times 65. So we have half on the left side, and this equals e raised to the power of negative of 0.103 times t. Now we apply natural logarithm to both sides so that we can solve for t. So therefore we get natural logarithm of half, and this equals natural logarithm of e raised to the power of negative 0.103 t. And using the power rule of natural logarithm, I can put this expression, that is a negative of this quantity, into front. And so therefore this becomes, in the next step, I write natural logarithm of half equals negative of 0.103t times natural logarithm of e. And so we can solve for t from this equation. We know that natural logarithm of e equals 1. So we can just ignore this quantity. So let me just remove this from the equation. And now we solve for t from this equation by dividing both sides by this quantity, that is negative of 0.103. And rearranging for t, we get the equation for t equals natural logarithm of half divided by negative of 0.103. And we can put this expression into the calculator. And when we do that, we get approximately 6.73. So we see that it takes 6.73 years for the population to reach half of the initial population. And since we have to determine the correct year, that is the exact year in which the population becomes half the population, we add the 6.73 to the beginning of the year. That is, the beginning of the year is 2011. So if we add 6.73 to this, we will get 2017.73, or we can say that in year 2017, the population becomes half the population of the initial population. And so the answer for this question is year 2017.